Now here we have to solve the equation x square plus x plus 1 equal to 0. Now if you observe the coefficients carefully, we cannot factorize this by splitting the middle term. So we would solve this equation by the formula method. For that we need to compare the given equation with the general form. So comparing with the general form is given by ax square plus bx plus c equal to 0. We obtain the value for a as 1, the value for b also 1, and the value for c also 1. So a, b, c all are equal to 1. So first of all we obtain the discriminant, that is delta. So delta is calculated as b square minus 4ac. So that would be 1 square minus 4 times a, that is 1, into c, again a 1. So we have 1 minus 4. So finally we have the value for delta as negative 3. Now this could be written as 3 times negative 1, and negative 1 could be replaced by iota square. Now we know that the value for iota, the imaginary unit, is negative 1. Hence iota square would be negative 1. And now we could easily obtain the values for x, which is minus b plus or minus root of delta upon 2a. Now we substitute all the values. So we have negative b is 1, plus minus root of delta is 3 iota square divided by 2 times a, that is 2 times 1. So if we simplify this, we obtain x as negative 1 plus or minus root 3 times, now square root of iota square is simply iota, divided by 2. So finally we have two values for x. First is minus 1 plus root 3 times iota divided by 2, and the second is minus 1 minus root 3 iota divided by 2. So this is the required solution set. The question is, find the missing value of k if the roots of the quadratic equation x square plus 3x plus 2k equal to 0 are equal. Now we know that if the roots of quadratic equation are equal, then the discriminant value, that is b square minus 4ac, must be equal to 0. So let us obtain the discriminant first. So for that we make the comparison with the general form. So comparing the given equation with the general form, that is ax square plus bx plus c equal to 0, we obtain a as 1, the value for b as 3, the value for c as 2k. Now we know that for equal roots, delta, that is discriminant value, is 0, but the discriminant is given by b square minus 4ac, right? So we could say b square minus 4ac must be equal to 0. Now let us substitute all these values here. So we have 3 square minus 4 into a, that is 1, into c, that is 2k, is equal to 0. So 9 minus 4 times 2, so that becomes 8k, is equal to 0. So transferring this on the right hand side, we get 9 is equal to 8k, or we could write this as 8k is equal to 9. So bringing down this 8, so we get the value for k as 9 upon 8. So this is the required value for k. And the question is, solve the equation 5 raised to x plus 1 plus 5 raised to 1 minus x equal to 26. Now this could be split as 5 raised to x into 5 raised to 1, plus even this could be split as 5 raised to 1 into 5 raised to minus x is equal to 26. So here we have used the laws of indices. So this becomes 5 times 5 raised to x plus 5 times, now this could be written as 1 upon 5 raised to x is equal to 26. Now before we proceed further, we make a small substitution. We put 5 raised to x equal to a. So therefore the equation changes to 5a plus 5 into 1 by a is equal to 26. Now we multiply throughout by a and we get now this term into a. So this becomes 5a square plus, now if we multiply 5 into 1 by a into a, so a gets cancelled out and we are just left with a, equal to, multiply the right hand side also by a, so we get 26a. Now we just rearrange the terms of this quadratic equation and we get 5a square minus 26a plus 5 is equal to 0. Now splitting the middle term, now 5 5 is 25 and 25 ones is 25, right? And 25 and 1 that gives a total of 26. So we split the middle term as 5a square minus 25a minus a plus 5 is equal to 0. Now in the first and second term, we take 5a as the common factor. So within brackets, we are left with a minus 5. And in these two terms, we take negative 1 as the common factor. And we are left with a minus 5 within the brackets is equal to 0. So we have two factors, a minus 5 and 5a minus 1. So let's proceed. So the two factors are a minus 5 and 5a minus 1 is equal to 0. So we have two values for a. So either a minus 5 is 0. So from here we obtain the value of a as 5. Or 5a minus 1. If this is equal to 0, we get 5a is equal to 1. So therefore, a is equal to 1 upon 5. And now we go for resubstitution. Now, the original equation is in x, not in a. But we have taken a in place of 5 raised to x. So, we again replace a by 5 raised to x. So for this case, let me split this. So therefore I could say 5 raised to x is equal to, now on the right hand side we could write this as 5 raised to 1. So if we compare the powers over here, we obtain the value for x as 1. So this is one of the values for x. Let's do the same thing over here. We replace a by 5 raised to x, and on the right hand side, if we take the reciprocal, we obtain 5 raised to minus 1. Now again we equate the powers over here and we obtain the second value for x, which is minus 1. So finally we have the values for x. X is equal to 1 or x is equal to minus 1.